Domestic cats, known scientifically as Felis catus, are the remarkable culmination of an extensive evolutionary journey. Their lineage traces back through millions of years, originating from small, nocturnally adapted felids. These ancient predators laid the groundwork for the agile hunters we know today. The story begins approximately 25 to 30 million years ago with Proailurus, often called the first true cat. This small, forest-dwelling carnivore already exhibited the fundamental felid body plan and specialized predatory traits. It marked a crucial early step in feline evolution. Around 20 to 8 million years ago, the genus Pseudaelurus and other Miocene felids diversified significantly. This period saw the emergence of multiple lineages, which eventually gave rise to both the big cats, known as Pantherinae, and the small cat lineage Felinae. This diversification was a pivotal moment. The definitive split between the big cat lineage, including Panthera and its relatives, and the small cat lineage occurred about 11 million years ago. This small cat branch ultimately led to the modern Felis genus and other small wildcats. It set the stage for the evolution of our domestic companions. During the Pleistocene epoch, spanning several million to roughly 10,000 years ago, regional Felis species and subspecies flourished. Early Felis species and ancestors of Felis silvestris occupied diverse Eurasian and African habitats. Felis silvestris populations specifically adapted to open and semi-open environments, where they specialized in preying on small mammals and birds. The critical turning point for domestication occurred approximately 9,000 to 10,000 years ago. The African wildcat, Felis silvestris lybica, began to associate with Neolithic grain stores and human settlements in the Fertile Crescent. This commensal relationship, driven by abundant rodent prey, was the primary catalyst. These wildcat populations, living in close proximity to humans, became the foundational source of today's domestic cat gene pool. Their tolerance for human presence and the reliable food source provided by agricultural practices initiated a profound evolutionary shift. This was not a forced domestication, but a mutually beneficial association. Cats descend from small, crepuscular or nocturnal felids that were highly specialized hunters. Their ancestors focused on small vertebrates like rodents, birds, and reptiles, particularly under low-light conditions. This specialization profoundly shaped their physical and behavioral traits. These ancestral hunters favored ambush tactics over pursuit predation. This selective pressure led to the development of exceptional stealth, powerful pounces, and precise killing bites. The entire sensory and musculoskeletal system that served these nocturnal predators became the core template for domestic cats. Vision for low light is a prime example of these adaptations. Cats possess a high rod-to-cone retinal ratio and a reflective tapetum lucidum. These features significantly improve dim light sensitivity, which is critical for effective hunting at dawn, dusk, and throughout the night. Their hearing and whisker systems are equally remarkable. Enlarged, mobile pinnae allow for precise sound localization, while sensitive vibrissae, or whiskers, detect and localize small, often silent prey in darkness. These sensory tools are indispensable for their predatory lifestyle. Retractable claws and paw pads are another key adaptation. Retractable claws enable silent stalking and provide a sudden, firm grip on prey, while remaining sharp when not in use. Paw pads further soften footfalls, enhancing stealth during ambushes. Musculoskeletal changes also played a vital role. A flexible spine and powerful hind limbs allow for explosive leaps and rapid acceleration over short distances. Their limb proportions and shoulder structure are perfectly suited for pounce and subdue tactics, maximizing hunting efficiency. Their dentition and skull reflect their specialized diet. Sharp carnassials and canines are designed for shearing flesh and delivering a precise killing bite to small prey. Their skulls retain the biting mechanics of highly efficient small prey specialists. Metabolic and behavioral adaptations include intermittent, high-intensity activity cycles, often referred to as polyphasic sleep. Crepuscular peaks in activity reduce overheating and align perfectly with the activity patterns of their primary prey. This energy-efficient strategy is a hallmark of their survival. Early small felids thrived in diverse habitats, including wooded edges, scrublands, savanna mosaics, and agricultural fringe zones. These areas provided abundant rodent prey. Many ancestral small felids were habitat generalists, adept at hunting in undergrowth, across rocky terrain and in semi-open environments. Their feeding pattern was primarily solitary and ambush-based. They hunted small mammals, birds, reptiles, and large insects. Hunting activity concentrated at dawn and dusk, with additional nocturnal activity when low visibility favored stealth. Feeding bouts were interspersed with long rest periods to conserve energy. Home ranges were typically small, centered on reliable prey patches. While generally solitary hunters, some species exhibited social flexibility, forming loose aggregations where food was dense. Maternal care for kittens was a crucial social aspect, ensuring the survival of the next generation. The ecological flexibility of these early cats was paramount to their survival. Their ability to exploit diverse prey resources and habitats allowed them to persist through significant climate and ecosystem changes. This adaptability provided a strong foundation for their future with humans. Their low-energy ambush strategy was also a key advantage. Short, high-power hunts followed by long rest periods reduced daily caloric demands compared to cursorial predators. This strategy was crucial for survival when prey availability was patchy or unpredictable. The commensal relationship with humans proved transformative. As humans developed agriculture, wildcats that tolerated proximity to people gained reliable access to rodent prey around grain stores. This consistent food source was a powerful selective pressure. Natural selection favored individuals with reduced flight distance and increased tolerance towards humans. This behavioral shift set the stage for domestication, rather than requiring dramatic morphological changes. The cats essentially domesticated themselves through this ecological niche. Genetic continuity played a significant role in this process. Domestication was largely a behavioral and ecological shift from a wild small cat ancestor, Felis silvestris lybica. The domestic lineage retained the core survival toolkit of its wild small felid relatives, ensuring their continued success. The evolutionary progression of the domestic cat can be summarized through key species. Proailurus, 25 to 30 million years ago, established basic felid traits as an early small forest predator. This was the foundational step. Pseudaelurus and other Miocene small felids, from approximately 20 to 8 million years ago, diversified into multiple small cat lineages. These lineages later produced the various branches of modern Felidae. The ancestral Felis lineage, spanning the Miocene to the Pleistocene, comprised small wildcats. These cats occupied Eurasian and North African habitats, refining their ambush adaptations and nocturnal or crepuscular habits. Felis silvestris and its regional subspecies, from the Pleistocene to the Holocene, were local wildcats. They adapted to open and semi-open environments, including the margins of human agricultural areas. Finally, Felis silvestris lybica, approximately 9,000 to 10,000 years ago, underwent a behavioral shift. This led to commensal and then domesticated populations. Their spread and diversification into modern domestic cats occurred through human movement and selective breeding. Modern house cats retain a remarkable ancestral toolkit. They exhibit crepuscular activity peaks, possess strong night vision, employ silent stalking techniques, and maintain a preference for small prey. These behaviors are direct links to their wild heritage. Their survival, whether in feral situations or within human homes, depends on the same flexibility that allowed their ancestors to persist. This includes dietary breadth, high reproductive potential, and behavioral plasticity. These traits enable them to exploit human-altered environments with great success.